teach the AI to do what it needs to do in those areas?
Thanks, Chris. It's really a good question. Actually, if we look at LLM and many the frontier AI technology tools used, actually they take a lot of domain expert and humans knowledge. So for us in the maritime, what do we do under the maritime research program? I think that one of the very outstanding example is our near-miss case detection. Actually, this one we have been working with vessel traffic system department of MPA over quite many years. I think Mr. Chen is there, and Ms. Chen gave us a lot of support, and we do the project with the port control center colleagues. So I think first, why we can identify the near-miss case detection is important. It's a research topic that is through the discussion with the domain expert, because near-miss cannot be captured by the manual reporting, but it's very important. Then once we use the AI and big data detection kind of technology to detect the initial candidate, actually we still need to go back to the domain expert, because only they will be the one to decide whether this is a near miss that we should learn from it. And it's important for us to establish new SOP and use it to train our junior maybe operator, and it's valid for us to do something more. I think this one actually, for us, I'm not from the marine background. We have, in the team, we have people study marine science and so on, but basically we are data scientists. Yeah, so we can detect something, but only the expert could tell us, is that insights, is that meaningful? Actually, a lot of knowledge of them have been embedded into the AI tools. Yes, so, and follow also what James have been shared. So it will help us to see a lot of the things, something potentially previously we might not be able to achieve, but with AI as a technology, we can see, we can do more, but that more go to a specific domain like maritime. It's a lot of expertise, a lot of experience, and it's a complex system. So we have to work with the domain expert together. And we don't see this one will replace the VTS operator, but we'll help them see something they didn't see fully.
That's excellent, because yeah, I think one of the things we see, like either in the technology space or in the GIS space, is AI is not making us become a developer, or it's not making us become a GIS professional. It's just helping us enhance our decision making in those areas, but as you mentioned, leveraging still the human in the loop.
I think it depends on their application definitely, but today I see maybe the like a cloudy code, this kind of programming things, yes, working very well. So yeah, I think definitely can leverage on that than other GPT kind of LLM models. We see it can help a lot. Also the agent comes, but I don't think we need to jump to the agent first. Maybe we need to look at some specific AI individual technologies. We know what it can do, what it cannot. Then we can move to the agent, so-called, we can coordinate and use LLM to link them up, I think, basically.
Great point, yeah, so I think that's the thing, is we talk about AI assistants, agentic AI and things like that. I think it's understanding what really is the next thing. So, James.
Yeah, for me, I would say that, like what Lawrence says, today the large language model, if you read the news and follow, there's small language models, maybe 4 billion parameters, then there's 7 billion, 13 billion, 30 billion. The bigger the model, the more powerful it is, right? But then you need a lot more computational power. So I would say that for maritime, maybe we need to find one model that can be trained with all your institutional knowledge, things that are very valuable for international community, whereby this particular model is a maritime model. This is a so-called specialist that you go to. Because for us, we will often need to go to the data source to find and dig through certain regulations or certain standards. But if you have a model that's specifically trained in that area, then that model can give you the data very quickly. Of course, precisely because I think Flora talked about agentic AI also having some issues. I have a lot of experimentation with OpenClaw, and I can tell you it burns my money through like nobody business. I don't think we can afford it. It's very powerful, but not ready yet. So a large language model that's very well trained in the maritime area cuts down the amount of inference that it needs to do to connect to the data source. You can get the data respond very quickly, will be something that maybe someone will want to look at and quickly build that model. Maybe you become, I don't know, I thought that the entity that have it will probably become rich first. That's my speculation, yeah.
No, and that's a great point, because I think what that emphasizes is don't just take the language learning model on face value. It's constantly got to learn, and it's constantly got to grow to become a better language learning model. So as you say, bringing in the right expertise, growing that to a model that then is utilized to more people, and they might even advance that further as well. So Lawrence, over to you, which I'm sure you'll touch on something on the geospatial context, which is close to my heart. So I'll end on that.
Yeah, I will. So I think it's a great session today. So most importantly, let's also get to the foundation of AI a little bit. Sorry. So the first is AI is just a very broad word, right? We still have a classic ML, machine learning model. Still have deep learning that use neural network to basically do inferences. And then lately, through 2022 and towards now, we have these large language models that's really powerful, able to code and do a lot of coding. I think for maritime, a lot of it doesn't really matter which model you are using today. It doesn't have to be LLM. It can also be a neural network model has been really trained on acoustic, let's say, to basically listen to different kind of engine sounds to find anomalies in the ships itself. It can be a planning agent which uses LM to basically planning your routes and stuff through geospatial kind of data that's been available. So all of these basically can pretty much use AI. However, as what I've just recently learned about, right? I think it's still a lot of it is at the early stage of exploration, and then that's great. So I think it still requires human to basically be the ones to make the decision. So for example, right, if we actually build a navigation system using AI, end of the day, as a bridge watchkeeper who is sitting at the top of a ship, they still need to be able to understand how does the AI even make decisions on, how is it turning, right? You can't have an AI that's just totally unreliable and then just make a certain maneuver without really explaining to you. So that to me, it feels like, okay, we need AI, but at the same time, we also need explainability in the AI for whenever you make a certain decision. So that's on the navigation. And then on the acoustic anomaly detection, right? I have a friend that actually has been successfully deploying acoustic models using neural networks into Navy ships. And it's really, really great they are doing that, because it actually reduces, the hardest thing that you can think of as a Navy ship is that your ship goes in the middle of Pacific Ocean and then it basically stops, engine stops. Most of ships can come with 3-4 different type of engines, to make sure that at least any point in time you should have at least 2 engines running, but you cannot afford if you have, your engine just suddenly shut down, some kind of lock happens because the water jet pulls something up in the seagrass and then basically interlock your entire engine. And that happens before. So with AI, you can do acoustic sounding, but accuracy is about 60. Accuracy can drop a lot the moment you have one model deployed from one ship to the other ship. So it's really having to retrain, and per ship has to basically redo a kind of AI retraining based on the local data sets, because every engine sounds different, every engine is designed differently, and there's water jet, there's different kind of propeller, there's so many different kind of engines and different parts that requires specific training data, right? So I think we definitely at the stage is very, very, I would say very exciting, and we have a lot of stuff to do, be coding, be taking data sets, be labeling and understanding what the industry needs. But all in all, I think we just need to understand the fundamentals and then crack through, everything one by one.
Yeah, Lawrence, great points. I think what you just touched on there, and I think it's where, James, you had this in your AI presentation, which was how you're looking not just at the language learning models, there's lots of different elements that AI can pick up and support when it comes to predictability, looking at the automation processes and things that AI can help with. So it's more than just, you know, a location thing, which obviously is an interest of ours, but there's lots of other, you know, the powers behind that as well.